All right, y'all, 10.3. Let's talk arcs of a circle. All right, so you know about pizza, right? Pizza is just a big old circle, a delicious circle. And here's a question for you. Hey, how would you cut a pizza into 8 equal pieces? And you might be thinking, well, duh, you just take your little slicer and you cut it. I guess a better way to answer that is how do you make those 8 pieces equal? Well, you might want to say, well, why don't you just cut it in half, right? Cut the pizza in half, and then cut those halves in half, and then cut those halves in half. Like keep halving it, right? Until you have 8 pieces that are exactly equal. Well, one question to consider is, well, how do you know they're equal slices? How do you know one slice is bigger than the other? Well, there's 2 ways you can think about this. If this angle here is equal to this angle, then these pieces of pizza are the same size. Another way to think about it is, well, how about the outside of the crust, right? The crust of the pizza is called an arc of the circle. And if this arc here is the same length as this arc here, then these pieces of pizza are the same size. And you want the pieces of pizza to be the same size because everybody loves pizza and nobody wants to get a smaller piece, right? So anyways, well, what if the question was, well, what is the angle of each piece of pizza? Well, notice we divided this circle into 8 pieces of pizza. And do you know how many degrees are in a circle? Hopefully you said 360. And so for us to find the measure of this angle or the measure of this arc, we can just divide 360 by 8 because there's 8 pieces of pizza and we get 45. What that means is that this angle here is 45. This angle's 45. It makes sense, right? 45 and 45 is 90. This is a 90-degree angle. Put them together, yep, 90. Each angle here is 45 because we divided this pizza into 8 equal pieces. All right, cool. Let's talk arcs, all right? What the heck's a measure of an arc? Well, I guess the best way to think about it is take a look at this arc here. Now, do you notice that this is half of a circle? The arc in blue, it's half of a circle. Well, on a full circle is 360, so half the circle would be 180. The measure of an arc, first of all, it's measured in degrees. And the measure of the arc is going to be the same as the measure of this angle here. Now, this angle has a special name. It's called a central angle. I'll get to it here in a bit. But if the central angle here is 120 degrees, then the measure of that arc is going to be 120 degrees. If the measure of this angle, the central angle is 90, then the measure of this arc is going to be 90. Likewise, hey, what's the measure of this angle? What angle? Well, it's a straight line, right? It's a straight angle. And a straight angle. Yeah, and a straight angle measures 180. Well, this arc across from it measures 180 as well. Take a look at this one. This angle here, the central angle is 30 degrees. Well, the arc's measure is 30 degrees. So that's an arc's measure. It's measured in degrees. Full circle is 360. Half a circle is 180. The arc is 180. 1/4 of a circle is 90 degrees. So on and so forth. All right. So as you know, 360 degrees in a complete circle. Now we need to talk central angle. This is an important definition. A central angle is an angle whose vertex is on the center of the circle. Take a look at this angle here, the angle AOB. That angle, the vertex of that angle is where? It is on the center of this circle. Because the vertex is on the center of the circle, this angle is called a central angle. That's important because the measure of any arc is the same as the measure of its central angle. So, well, what's an arc? Well, here's a definition for you. An arc is a portion of a circle. And an arc is formed by an angle or by 2 lines that cut through the circle. And so what we would say is this angle, this central angle, intercepted the circle at this arc. And we would call this arc AB. And this angle intercepts arc AB. And so the central angle, like I said, when it cuts into the circle, it divides the circle into two portions. It divides it into two arcs. Look, we got this big arc here, and then we've got the small arc here, right? Well, the small arc is called the minor arc. That's the smaller arc that's formed. And the measure of that smaller arc is the same as the measure of the central angle. So if this angle here measured 20, AB's arc would measure 20. And then the other side is called the major arc. So any angle divides a circle, any central angle divides a circle into two arcs. You got the minor arc, smaller one, and you got major one, bigger one. And so you could name the smaller one AB, but you'd have to name the major arc with 3 letters. A, and pretend there's like a C out here. You could name it ACB. And so you use 2 endpoints to identify a minor arc. You need at least 3 letters to identify a major arc. Okay, mostly we're going to be dealing with minor arcs, but you do need to know these definitions of minor and major arcs, okay? Also, semicircle. So a semicircle is half of a circle. And basically, if EF here is a diameter of the circle, that means that this arc EF is 180 degrees, and it means this whole region here is exactly half of this other half of the circle. But it's called a semicircle, okay? Here's another thing to know about circles. All circles are similar, but not all circles are congruent. If 2 circles are congruent, that means they have the same radius. Take a look at these 2 concentric circles. You've got one circle here inside of a larger circle. Well, these circles clearly are not congruent because they're not the same size. They're similar, but they're not congruent. They would only be congruent if they had the same radius, and they don't. The smaller circle's radius is this big. Bigger circle's radius is this big. Am I right? What else? Congruent arcs. So an arc's size and an arc's measure is different. Take a look at this arc AB versus this arc CD. Because they share the same central angle, you see this is a central angle, it's 65 degrees. Since the central angle is 65, the measure of AB is 65 degrees. The measure of CD is also 65 degrees. But the arcs are not the same size. So a size of an arc is different from the measure of an arc. And arcs are only congruent if they have the same size radius and if they have the same measure. I hope that makes sense. Let's talk about these example problems here. If you were given, and this is how you write an arc, you do like an arced little line or whatever. It's a curved line above 2 points or 2 letters. The measure of AB. So the measure of AB is 20 degrees. What does that mean? Well, it means the central angle is 20 degrees. But what do we have to find? We have to find ACB. Okay, ACB. They're talking about the major arc, right? Well, if the total degrees in a circle is 360, then can't we just subtract 20 from 360 to get what this arc is? Whoops. Yes, we can. And so here, let me see if I can find this in the book. Bam. Yeah. So we just need to subtract, to find this major arc, we just need to subtract 20 from the total 360 in a circle. And then we get the leftovers, this black arc. Okay, it's 340. Well, how about this one? If you know that the measure of this angle here is 110, that means that this arc here is 110. But if you need to find the major arc, x dy, then how do you do it? Well, you just subtract 110 from the entire circle, which is 360, right? It's 360 minus 110, you get 250. That means that the leftovers here, this black curve, this arc here, is 250. Okay, cool. So that's measures of arcs. The measure of an arc is the same as the measure of its central angle. It's only a central angle if the vertex is on the center of the circle. Vertex on center of the circle. Couple of theorems for you. Um, these theorems are related. They're kind of paired together. Okay. First, if two central angles of a circle are congruent, so this one circle here, if these two angles, notice they're both central angles. If these two angles are congruent, then what does that mean? It means that the arcs must be congruent. The arcs that the angles intercept must be congruent. And so if these tick marks indicate these angles are congruent, that means that PQ, arc PQ, is congruent to arc SR. Now the reverse of that is true as well. So you got two theorems. One is saying if central angle congruent, then arc congruent, arcs congruent. The other is saying if arcs congruent, then central angles are congruent. So if these two arcs are congruent, then the central angles are congruent. Now this works within the same circle, but notice it also works for congruent circles, okay? Usually you're gonna use this theorem, either of these theorems, within the same circle, all right? So that's two theorems. Let's see, how about an example problem? Let me see if this is in the book. Okay, here we go. Given that B is the center of the circle and D is the midpoint of an arc. Look, what does that mean? Well, that means that if D is the midpoint of this arc AC, that means this arc here is congruent, AD is congruent to DC. Do you agree? And so if you had to prove that BD, this ray BD, is a bisector of this angle, how would you prove it's a bisector? Well, wouldn't you do that by proving these two angles are congruent? Yeah, and you can, because, well, if two arcs of a circle are congruent, then their corresponding central angles are congruent, all right? That's how you would use that theorem in a proof. There's also find problems. Let's see. Well, let me give you the rest of the theorems before I show you a find problem. So these two theorems, they're related, they go together. If two central angles of a circle are congruent, then the corresponding chords are congruent. Remember, a chord is just a segment that intersects a circle at 2 points. So notice, this central angle, Q, O, P, it has this chord here, PQ. Well, if this angle is congruent to this central angle, then both of the chords must be congruent, okay? Now, the reverse of that is true as well. What if you know that the chords are congruent? Then what could you say? You could say then that the central angles must be congruent. So here's two theorems, and it works both ways. Now, these are very closely related. Look, central angles congruent, arcs congruent. Notice the chord would be right here. Do you see it? The chord would just be right here. Okay, well, it's very closely related. So if these two central angles are congruent, the chords are congruent, but the arcs are also congruent. Look at PQ, arc PQ, it's congruent to arc SR. And that's basically what this last two pair of theorems is saying. So you get that all of them are congruent. Basically, if two arcs are congruent, then those corresponding chords that intercept the two endpoints of the arc, those two chords will be congruent. If the arcs are congruent, the chords will be congruent. The reverse is true too. If the chords are congruent, the arcs are congruent. If the chords are congruent, the central angles are congruent. If the central angles are congruent, the arcs are congruent. You get all three of these things being congruent, okay? It works within the same circle, but it also works for congruent circles. How do you say two circles are congruent? You have to show that their radius, the radii of each circle, is congruent, okay? Let's see, what else? An example problem? All right, let me show you some example problems. So you've got these 6 theorems, which seem like a lot, but they're all saying basically the same thing. It's just that there's a relationship between central angles, chords, and arcs, okay? And then don't forget all of these definitions. Let's look at some example problems. All right, let's see here. Okie dokie. If the arc AB is 102, then find the measure of A and B. Okay, we could do that. Well, if this arc is 102, what does that mean about this angle? It means the central angle is 102 as well. Okay. And we need to find the measure of A and the measure of B. Now, what do you notice about this triangle? AO is a radius, is it not? So is BO. All radii are congruent. So if these two are congruent, aren't the base angles congruent as well? Yes. Which means that you could say that the measure of A, call it x, and the measure of B, call the measure of B x. Well, they equal the same thing. And don't the three angles of a triangle sum to 180? And if this is 102, you got 102 plus 2x, right? 102 plus 2x equaling 180. Well, this is just a simple algebra problem now. If we subtract 102, what do we get? What is that, 78? And then if we divide by 2, 78 divided by 2 is 39. Does that make sense? And it's only because these two are congruent, all right? What else? Yeah. Ooh, okay. How about this question? Find the fractional part of a circle. Wait. What fractional part of a circle is an arc of 36 degrees? Okay, well, if it's 36 degrees, what's the fractional part? Here's what they're saying, right? If you got an arc that is 36 degrees, well, what is the fractional part of that arc to the whole circle? And, well, how do you do that? Well, you do whatever the arc's measure is over the whole circle, which is always 360. So if the arc is 36 over 360, that reduces to 1/10. And so this arc, which is 36 degrees, is 1/10 of the circle. Okay, that's all. Check out the homework. This will be a 2-day assignment. Well, no. I'm gonna give you one homework assignment today. Tomorrow's a continuation. Okay, bye.